Thank you so much, Dr. Jahangeer Ali, sir, for your early morning time at USA. And so let me introduce the Dr. Jahangeer Ali. Dr. Jahangeer Ali has completed his MTech from the National Institute of Foundry and Forge Technology, Ranchi. Uh, and after his MTech, he has went for his PhD program at IIT Roorkee. And sir has joined the University of Nebraska Lincoln and for as a research associate. Uh, then after he has joined there only as a assistant professor, community and regional planning program, College of Architecture, University of Nebraska Lincoln, and from that time he's still working there, and he has a large number of experience and wide number of research experience in the field of environmental sciences and this data analytics, deep learning, and various fields. Sir has worked as a research associate in various universities of USA and Nebraska also. So I welcome you, sir, because the participants are already continuously joined various sessions of this FDP. So on behalf of Sriyash College of Engineering and Technology, Chhatrapati Sambhajinagar, Maharashtra, India, I welcome you, sir. And all the participants, I want to say that this time the government of India has make a new rule that for Atal FDP, there should be at least two resource person from the abroad, that is outside the India. So I requested Dr. Jahangeer Ali to be the part of this FDP and deliver the session. And sir has agreed to be the part of this FDP, and he accepted our request to deliver a lecture, expert lecture in this FDP. So I welcome you, Dr. Jahangeer Ali. Now the session is yours. Please start.
Yeah, thank you, Dr. Tonde, for a wonderful introduction. So I'm Jahangeer, and I'm working here as a research assistant professor. And my work basically related to water resource modeling and environmental modelings. But one project we got here in the University of Nebraska is about how we can get the space for truck parking in the Nebraska in the bad weather. Like here we got a lot of snow, a lot of storms. So we need to study using some modelings or assessments where we can get the parking space for large trucks. So I'm going to discuss about my project. One of the case studies are deep learning for truck parking management along IIT Nebraska. So IIT is interstate. This is passing from the whole Nebraska. This is around 775 kilometer highway. So this is about my overview of presentation. That is, why this is moving so fast? Using data-driven tool to solve infrastructure, safety, and environmental challenge. Second, how we are going to integrate artificial intelligence with the remote sensing data to make a efficient planning, as we are working in the Department of Planning. So we need where we can get the space, where we can get the safety, where we can get the services for the truck drivers. So we need to develop some planning space, and how this can lead sustainable transport load to reduction fuel waste, emission, and accident. One of the main reasons for this project, as lot in the bad weather, lot of accident happens due to the snow and storm weathers. So if truck park on the highways or side by highways, so they have the more chances to get the accident. During bad weather, there is less visibility and there is slippery roads. So that's why the Department of Transportation is very curious about how we can solve this problem in real world. So we start a study using some deep learning models and assessment with the past data to see how we can overcome this issue in the Nebraska. So this is about my case contest. What is the required? That is JSON law identify nationwide shortage of truck parkings. So there is a law in transportation that's called JSON law, and according to that, every truck driver's need after 8 hours of continuous driving, he needs a rest. For that things, we need the parking space at a specific locations. Because if truck driver miss some parking space, then he need to drive at least 300 400 miles for get the next parking. So unsafe roadside parking leads to safety plus efficient problems. Third is this is IIT highways lacking adequate facilities because it is a midwestern states. And how we resolve this problem, that is what is the evidence based and spatial analysis to see where is the actually we need the parking spot, where is the more load, where is the less load, why truck drivers is curious to park about the near the city. So if you look this picture, this is my study area. This is a map of Nebraska, and we have total public and private parking facilities around 70, and 3 parking facility. Latestly, they are that's called the future. In the future, they are going to make some parking facilities. So if you is my skin visible? Hello, hello, Dr. Tonde,
Yes, yes,
is my skin visible?
yes, visual, sir, visual. No
Okay.
problem.
So this is my study area. If you look, we have 70 parking facilities that
Can
divided
you
according to
make it
public.
more full screen? The next slide, it is showing like, can you skip that one? I mean, full screen, make it full screen.
I am already in full screen.
Yeah, okay, please go ahead. Okay.
Now it's okay.
Yes, yes, that's it. Okay.
So we have total 70 parking space here. Those are divided into public and private. Public is like that thing taken by the state government or federal government, and the private is like some brands which provide the services like Cassie store or truck stores. So they have the parking site. So those parking sites divided by according to facilities like public parking site facility have facilities like they have the washrooms there, they have the some sitting place there, they have like some uh, little shops for the purchasing the things for their foods. But the private one have like they have the petrol pump there, gasoline stores, and they have the restroom there. They have the even hotels there. So we need to look what is the behavior of truck parkers to park the truck in those sites. Public site is a free, but private site they charge for the according to their if there is a more demand, then they charge more. If demand is less or advance booking, then they charge according to that one. So for the my analysis things, this is the general raw pictures of like I use the 2 type of data. One is the NAIP, that is National Agriculture Imagery Program for the US. So every 2 years they have one picture of one is at particular place. And Google Earth image is like they monthly or yearly updated. So we took this type of pictures uh, for our whole Nebraska, and then we analyze how we get the current scenario of parking in Nebraska. So on the basis of this uh, literature and little bit analysis, then we identify in 3 main research objectives. One, we analyze the how much in the past decade truck parking trends in Nebraska. Then we'll train a YOLO V7 deep learning model for truck detection using the imageries. YOLO is you look only once. This is the deep learning model. So we modify this model according to our data requirement and then try to detect automatically detection of parking space. And on the basis of these spatial temporal mapping and YOLO modeling result, we develop some planning and policy recommendation for next suitable site in the corridor. So this is data framework we use. So NAIP imagery is like a 1 meter resolution, but that provide almost in the 2 year or 1.5 year. And the Google Earth image is a 0.6 meter resolution, but very interval variable. Sometimes they update monthly, sometimes they update in the 6 month. And in the Department of Nebraska Transportation provide us like 70 sites. And we use these data automation like a manual sometime, and sometimes using labeling like this is the parking and this is the non-parking space, or this is the truck or this is the car. So this is the workflow about how we uh, initiate our study. So we have the image, then we use that as an image in data processing. Initially we divide image like we denote this is the car, this is the truck, and this is the blank space. Then we give that data to YOLO framework, and on the YOLO framework we arrange the data according to YOLO framework requirement. Then we train the model and validate the model, and then automatically detect the truck. And this right hand picture is a this is the inside of architecture of YOLO models. And YOLO model is YOLO 7 is developed by Wang et al. In 2023. So we took some basic things from there and add our data source in their codes to develop a model according to our requirement. So YOLO model have like a 4 basic part: input, that's called a backbone. Second is the backbone, and the neck component and head. So they divided, they use different machine learning deep learning model inside the structures to get the output. And this model is already trained for more than 93 classes. So if you want to add this type of model in your study, you just add your data set and trained, and the model is trained according to your data. On the basis of this analysis, we quantify the first spatial temporal parking analysis throughout the Nebraska. So the graph is above. We divided the truck parking space eastbound and westbound. Means on the east side of parking space or west side of parking, because most of the public truck parking spaces either opposite or there is a gap between 2 miles between those sides, like east side, then after 2 miles the west side, then after 100 miles east side or west side. So if we see the picture is most of the sites showing the more than 100% occupancy rate, means is the we have the truck parking space 7, but they park like 8 or 9. So why they park the 8 or 9? Because they didn't get the space, so they just park there. They need to stay for after 8 hours, they need to rest down. So we found on the basis of these are the for public facilities only using the NAIP data, because NAIP data have picture after every 2 years. Then we analyze the data for using the Google Earth data sets. And in Google Earth also we see the most of the site is which are the nearby the city, they have the more than 100% occupancy rate. Means every time the truck parking space is like a 10, but they have park 11 or 12. Then we study this for the parking facility private sites. So in the private site, we found many sites is they have the more than 100% occupancy rate. Although they have the limited space, but always like truck driver want to park there. So these graphs showing the percentage of truck parking occupied at each private parking site facility based on the NAIP data, NAIP eastbound or westbound. Then this is on the basis of the Google Earth data. So on the basis of this analysis, we develop the map, spatial temporal, to see the where is the load is more. Then we analyze these data in the GIS or GIS Pro and run the ringing analysis to see where is the more load. So figure A like represent the eastbound and B is the westbound. So if you see that there is some red space, some green space, some blue space, yellow space, yellow color. So these depend on how the occupancy is changing. So these red spot is called the hot zone, because they always have the more than 100% occupancy rate. Means if they have the truck space parking number like 10, but they always parking 12 or 13. So we categorize 773-kilometer highway according to how they park there, what is the pattern there. So we divided this 0 to like 20%, 20 to 50%, 50 to 30%, and where is the more than 100%. So we identify the hot spots. So this is the hot spot using NAP data, and this for the private parking sites. So private parking, most of the site is eastbound is mostly overparked. They are the mostly overparked. So on the basis of these analysis, like we provide the some suggestion that is we need more parking nearby the like here a city is Kearney or Omaha. So we suggest that some parking space will be considered constructed in the Omaha or Kearney city. So on the basis up to here, we have analyzed the spatial temporal using the Google Earth image and NIP image by normal digitization process using GIS Pro. Then this work take a lot of time. So we need to develop a model. Okay, we can give the pictures and we can get the there is a truck parking space available or there is a noise space. So we use for that one YOLO model. So we trained our data according to model requirement.
Sorry to interrupt you, Dr. Jahangir.
Yes, please go ahead.
Yeah. So is the government of that Nebraska that they will allow the people, yeah, you, the researcher, to the analyze, yeah, get the some kind of accumulate some kind of data.
Yeah,
You
we
need
got no, we got almost 1 million funding for this project.
okay.
So basically, in the bad weather here almost 3-4 months is always a storm and snow. So we got lot of accident.
Okay.
So many accidents. So Department of Nebraska Transportation allow a study to find out the how we can get this truck is so in because here this is the long highway and it connect east and west. So all coming from the California to here.
Yes,
So
yes.
they use this corridor.
Okay. So
So
how many people you are working there, I mean, sir, in this project?
So in this project, we are three co-PIs and a couple of our PhD student and master student working.
Okay. Yeah, very nice. Means such kind of investigation should be done in India also because there are several, you Lucknow and Delhi, you expressway is there.
Expressway, yeah.
Yeah, and then Jaipur and Delhi expressway is there. There are a lot
But
of things are
there is a
happening nowadays.
issue like here the parking space is specific. You can't park according to rule. You can't park anywhere.
Okay,
Only so medical emergency, and
okay,
we don't have any like hotels or restaurant nearby the highway. So
okay.
they are the specific places like after 1 mile from highway. But in India, we have restaurant and little stores on highways, so we can park there easily.
Yes, yes.
But here is a like within 1 mile range, they
Okay.
allow the specific things.
Okay. Without government permission, nobody will open the restaurants and other things.
No, you need so many license.
Okay, okay,
And regarding restaurant is so many like human health issues, food issues. So they are very curious about human health.
okay,
So
okay,
for the fooding things, you need so many license.
okay. Okay, thank you, sir. Please go ahead. Yes.
So on the basis of past 10 to 12 years data, we find some spots where there is a tendency of truck park more. So then we look into the facilities available on those sites. And on the basis of those results, then we analyze, okay, this is the manual and time taking work. So can we develop a model like if we use the just picture, we can tell, okay, this is the parking space available there for the truck driver and they can park there. Or should we like develop like a IoT based model? So truck automatically no driver, okay, in the next parking space is available, so I can park there. So initially we trained the model on the basis of parking availability space, and we found the model accuracy is 90%. This that was a little bit okay. And then we comparison about observed and the detecting. So if you see the picture, we just give the picture to the database, to the model database, and then we found the okay, this is the detecting track is 90%, track is 80%. So on the basis of these analysis and model accuracy, as this is the preliminary data analysis, so we found that okay, YOLO V7 provide effective for track detection using imagery things. One of the reason for getting this accuracy a little bit lower is due to the image resolution. So NAIP have the 1 meter, and this Google Earth image has the 0.6 meter resolution. So if we have the image from the drone camera or specific uh, drones which have the very high resolution, then we can get more accuracy of the model. Then we run the model performance to see the if we change the threshold value, like okay, 50%, 60%, 70%, 80%, how is the recall or accuracy is varying. So in our case, the accuracy will vary little bit if we change the detection threshold things, like 50% detect track or 60% detect. So this is about the performance of model. So we get idea, okay, if we provide the picture to this model, then we can get the parking. Model can detect, okay, this is a truck or this is the car, because we classify our data on the basis of class. Now the question is how the truck driver will know, okay, there is a space. So we need to connect this with the automatic detection system, and then we use some GPS technology to, okay, truck driver can know the website or portal that is next space is this is the next site, and they have the this number of space free, this number of space is booked. So we are working on that one. So what from our analysis, what we got, normally eastbound or central eastern Nebraska consists more than 80% occupancy all last decades. Public rest area near Omaha over always over occupied. And why the truck driver park on the more on the private side? Because they provide more amenities, like they have the restaurant there, they have the very good food quality there, and a restroom, and they have the gasoline there. So one of the main reason to truck driver is we discuss with the truck drivers in the visit, why you park here, why you don't park in the public sites. So they mentioned, okay, we park here, and we got the gasoline also, we have the restroom also, we have hotels, so we can stay here. In the public one, we have only restroom and a little bit stores, which provide limited amount of food. So why this study is related to the sustainable development goal? So there is a sustainable goal 9 in which we mention the innovation and infrastructure should enable the high freight efficiency, sustainable cities, reduce roadside hazard, climate action for lower early emission, and the sustainable yet decent work means provide the work and safety for the employees. We are looking opportunity if we develop the model and integrate with the IoT web-based portal, so we can nationwide start automated monitoring using open imagery, and anyone can use, like they just give the image, just download the image, put on the portal, and get the okay, this is the place where we can park. We can integrate with IoT, real-time sensors for parking availability, and public-private partnership for smart city expansion. How we can attract drivers to park there? How we can attract drivers to don't park on the roadside? And once is code developed, then we can it's replicable open source AI model for use in other domains. What are the challenges to using the AI things? But one of the most common challenges is data limitation, because we depend on the data. How refined is the data? If the resolution of data is good or accuracy of data is good, then the another issue in the transportation thing, the low light issues, like if a parking site have the long tree, so aerial imagery will not detect if there is a parking site or there is some other space. Another is, during this type of study, we need to classify the class. Okay, this is the truck, this is the class, this is street, this is blank space. So that's called the manual labeling. This is a very time consuming work in the labeling things or classification of your detecting things. So that will need more accuracy or labeling. So we need some model like with that automatically label the things. Like we just provide the pictures or we just provide the image and model automatically detect, okay, these are the things in these pictures. Another thing is the imagery frequency and resolution. Like NAIP provide one image of one space, one place after every 2 years, because this is very big program throughout the US, and they took the picture throughout the US whole year. But like, okay, this is a Lincoln city. In the Lincoln, they will take one picture in 2 years. So, and track parking is a real time things, because we got the GPS data of 6 months, and we have the data row of almost 40 million row. Because every 3 second, after every 3 second, track position is going to change because it's moving. So we need a high imagery data sets for using as a picture as an input source. Then the ethical and equity concern in AI infrastructure, as because so many things happening in the AI, anyone can inject the data and produce something. So on the basis of these results, we suggest couple of sites where we can.
Okay, Jahangeer, sorry to interrupt you. Yeah.
Yeah, go ahead, please.
Yeah, this kind of infrastructure where the AI is implemented, machine learning will be implemented, deep learning and IoT will be implemented. So I want to know that who will bear the cost of these infrastructures?
So here in this project, whatever policy or planning we are
No,
suggesting.
no, not this project only. I'm telling that when this
Yeah,
project will be overall implemented throughout the Nebraska city or maybe the throughout the California,
yeah, I am coming to that point.
who
So
will
for the
be?
transportation thing, so our role is like we can provide only recommendation suggestions. Then Department of Transportation with the investors, they
Okay,
will develop the facility there.
okay, okay,
So
okay.
same thing happening in the, like I'm working on another project related to the water resource modeling.
Okay,
So we are identifying where is the next wetland will be formed
okay,
on the basis of AI and machine learning.
okay,
So
great.
we just suggest on the basis of our analysis, okay, these are the place where we can develop new rest area. These are the place where this land become wetland in the future.
Okay,
After that, the implementing agencies is the specific department. They will meet with the investors. They will organize the public hearing, and then they will go for the plan. Because every city here has a 50 years plan.
okay. Now,
What
my
will be the
question is
next?
that, like in India, there is expressway or highway is there. Okay, so the company who made that highway, they have the toll naka. Okay, uh,
Yeah.
the manufacturing cost of or construction cost of that highway will be collected by that toll naka company. Is is similar way is there in USA?
No.
Okay,
Here is the for the state provide the fund to city. City construct the road, if that area, and that totally like a high road divided into different type, interstate or highways.
okay,
So if they fund by state, so it's fully developed by state.
yes,
State will take responsibility. So they have the Department of Transportation for the road structures. Like for USDA, Department of United States Agriculture, they look about the land development.
okay, okay. Okay, please continue. Sorry to disturb you.
So we suggest like because we found the more load on the eastbound side. So three cities like Omaha, New York, and Central Nebraska is overoccupied always. So we suggest couple of more parking sites should be there. So truck driver easily get the facilities to park truck there. We also suggest we look into our result and see that more truck driver park into the private rest area, not a public. Even public have the space, but truck driver want to park in the private sites. So we suggest develop more private site using the PPP model, and then integrate real-time info system for truckers. Like we can get the real monitoring. Okay, this is the parking site, and next station is this one, and we have the number of parking space there is this, and how much is occupied, how much is free. So truck driver automatically know, okay, in the next 2 year, I will found this type of parking site, and we can use that one. And I'm going to use AI evidence base for long-term infrastructure funding decision. So as in now in last 5 years, AI is in the boom. Everyone using AI, machine learning, deep learning in their analysis results. So how we can utilize these AI things in the funding decisions? So another the product perspective of the AI is shift from reactive to predictive planning. We can predict. We can multi-sector collaboration, transportation, data science, environment, and like vision is intelligent, adaptive, and equitable infrastructure system for sustainable development. So on the basis of our analysis, we suggest like a YOLO V7 provide almost real world infrastructure planning for the truck parking. And with the help of machine learning, deep learning, or AI, we can efficiently enhance the safety and inclusivity. And the model framework are scalable for the nationwide deployment. Whatever model we develop with our data set, we can extend it to throughout the nation. So this was about my research project, which is going on. And we're also using AI and machine learning in the detection of future wetland things in throughout the US. So we analyze the last 6 year data throughout the US and see what type of soil is there, what type of how much is water present in which season. Then we predict next 50 years. And on the basis of our predictive modeling using machine learning approach, we use support vector, cart, and random forest. So we estimate the quality of soil and how much is water there, how much area covered by water, and then we suggest, okay, these parcels may be the future wetland in the US. My basic background is mostly on the water resource, so I just received funding for this project, and we are working on this one. So if you have any question, I'm open for that.
Dear participants, if you have any question, if you have any topic that will be discussed by the Dr. Jahangeer sir, so you are free to ask. Or Dr. Jahangeer sir,
Hello. Yeah.
yeah, if you have any other topic also related to this area, you can also discuss, no issues. Because we have some more time, more 15 minutes we have, you can discuss, no problem.
Yeah,
Okay.
Hello.
I can. Yeah. Hello.
Dr. Jahangir sir.
Yeah.
I have one question. As this session is on sustainability and how this AI can improve the sustainability of the manufacturing or the environment. So I want to ask, there is a major problem going on in the capital city, that is Delhi, that is of high air quality index. So how can we manage, or how can we monitor that AQI and control it using AI?
So we can predict AQI using AI. And for the control, latest example is how China is controlled for the Shanghai. So they just predict, okay, they just close down the industry for a couple of days, then settle down the AQI, and then they predict, okay, if industry is opening here, or how much is transportation load is here, then this much will be the AQI. So they settle according to their, they open or settle the transportation load according to their predicted values. And within 5 years, they are now under 60. So if you plan like by using the predictive modeling, using artificial intelligence, machine learning, okay, if this much of transportation load in the city and this much is the industrial load, how much will be the AQI in the next day or next week or next month? Then we can use the prediction, and then we can reduce the load. This is the only, according to my understanding, this is the only way we can move forward in the reduction of AQI in the Delhi or nearby cities. Like here in the Lincoln, if our AQI is above more than 62 or 63, then we can get the notification, okay, please inside home, don't use your vehicle. Today's AQI is higher. So if we have the then we reduce the load on the city in form of the transportations using cars or buses or different vehicles. So here is automatically monitored, like if AQI goes 65 above, we can get the notification. If people okay, we can go inside the home. We will not go to the office like this, or we can work from home. So the reason is like we are just reducing the load. If we predict a 1 week AQI using a predictive modelings, then we can adjust our load. Okay, we will get this much of load, this much of AQI on this load. So how we adjust the load? So AI will use in the prediction things. Is I'm able to give answer of your question?
Yes, sir. Obviously, it is a very complex problem, but it can be done or managed through AI.
With better management.
Yeah, we need to, people should also listen.
Can be controlled.
No, but nowadays in Delhi situation, people will listen. Because in the news, everyone is wearing mask, taking cylinders of oxygens.
Air purification system is also.
Yeah.
Definitely the people are responsible for and they have to manage and they have to control the loads, extra loads. Then
Yeah, no country is perfect.
yes, definitely.
In India, we are not taking responsibility.
Yes.
And here is like I'm from last 7 years here. I feel that okay, we are following rules, everything. So if we do the same thing in India, then India will be on the same position.
Definitely. Sir, I have heard that the city of Singapore has made their own digital twin and artificial intelligence system, which will detect everything, means where is the pollution is growing, where the means floods are there, where the choking of water sediment systems, sewage systems are there. Everything they are going to manage through the digital twin system, artificial intelligence, and IoT based systems. Means there is no need to go to the location. They will get the data at the system only, and the Department of Municipal Corporation of Singapore will have all the data, and they will predict the things. So, and within 5 years, they will have uh, all the system that will be managed by a computer system and software only. That digital twin system is there. What is your opinion about this?
No, I am also looking here. Every system, like if you need the water quality, they already predict. Okay, tomorrow your water quality is like this.
Okay.
Because every city has the tap water. We don't use here filter water. We just drink the tap water. So they send notification to every homeowner. Okay, this is the water quality. This is the air quality in your area. So everything is monitored if we have the proper installation of sensors, proper management. So most of the city here also working on the AI. Think how we can reduce the workforce on the people, and we just utilize AI. Even in the nowadays research, nowadays the university is not hiring graduate research assistant. They are using AI things. So because in research, if we hire one master's student, one PhD student, we need at least $600 million, $600,000, one PhD, one master's. And if we use AI things like different chat GPT or another AI tools, to write a literature review and then refine with many editings. Then we can easily produce. So nowadays here in the US academic system, they mentioning that don't hire GRA, just use the AI things to reduce the funding load to the agencies. So if we are not going to hire any PhD or MS position, then we just reducing 500,000 to the funding body. So this is a trend going on. Everyone is shifting to the machine learning, deep learning, AI things. So every industry is here is like a Tesla. Your vehicle is totally controlled. You don't need to drive. You don't need to look anything. So that is they are it's using the AI things. So many cameras, so many like sensors. So if we plan and we have the funding things, then we can achieve things there also. But the problem is who will be the responsible? Like in India, if we get the some funding, then how much amount going in this way, that way, and the final we get the limited amount for the project. This is another reason.
Yeah, yeah.
I'm not criticizing, but I feel in my little bit experience from here and there.
Okay, sir. Any other participant? Do you have any question? I request participants. You can also chat box. You can write in chat box. If you have any question, please. Any AI tool? Good evening, sir. Any AI tools for optimizing mechanical processes?
I'm not expert of mechanical, but I'm working in the developing our web portal using machine learning models for the water body detections. So I can share detail with them. If you share your email, so I can share the things with them. But I'm not expertise on mechanical engineering.
Okay. Okay, dear Giri Paras, sir, you can use the several nowadays various companies are developed their AI model like Kenna Metal is there for machining operations, and CATIA software is also CATIA, and AutoCAD has also their AI models for design optimization and optimization of the mechanical processes. So you can use those things, and the various companies like Fanuc companies there, Siemens are there. They have developed their own AI model for optimizing the mechanical processes. So you go through that, and if you have any query and if you have any discussion with sir, we will definitely connect with you. You can contact me later on. So
Please.
yes, sir. So thank you, Dr. Jahangeer, for giving
Thank you.
time. Yeah, there I think in USA it is 5 p.m. 5 a.m. at morning.
It's 6 a.m. now.
Okay, so at early morning you have given us a time for that. I'm very, very thankful to you and highly obliged to you also on behalf of Suresh College of Engineering and Technology, Sambhaji Nagar. So, sir, you have discussed your research openly with us. Thank you for that. And I would like to thank also our college management, Engineer Basavaraj Mangrule sir, who is our chairman, who has provided the wonderful and essential infrastructure for running this FDP. And I would like to thank our CEO, Colonel Joy Daniel, sir. I would like to thank our respected principal, Dr. B.M. Patil, sir. I would like to thank our Dean Academics and the coordinator of this FDP, Dr. P.M. Ardhapurkar, sir. I would like to thank all the faculty members and team members of the mechanical department, HODs of different departments. And at last, I would like to thank all the participants of this ATAL FDP. They have listened us the session vigorously. I would like to thank the AICTE, ATAL Academy, and the Government of India, Ministry of Education and Government of India. I would like to thank all the people who have supported us to make this session and this FDP a success. Thank you, sir. Thank you, Dr. Jahangeer, for being over here, and thank you for your time. And definitely, we will be in touch for the future endeavors, and we will
Thank
definitely
you.
connect
Thank you very much,
for any
Dr. Tonge.
research purpose and discussion purpose. Thank you, sir. Thank you, everyone.
Yeah, thank you, Dr. Tonde.
Yes.
I will discuss with you about what's going on in our research. If anyone is interested in the collaboration, then I will definitely go forward.
Okay, sir. Thank you, sir.
Okay. Thank you providing opportunity to discuss with you.
Thank you. All the
Okay.
participants, you can leave the meeting now. Thank you, everyone. Thank you.